Okay, applications of set theory. Let's say that we have some information on method of getting to school. So how we get to school? How some grade 5 students. So, let me see if I can draw out nicely. All right, 3, we'll call them circles. So car, bicycle, and walk. And what I'm going to do is I'm going to fill this in totally with the numbers, then we're just going to look at interpreting it, right? Just saying. Okay, so here's a totally filled in Venn diagram, right? And what we're going to do is just interpret this information. Then later on what we'll do is we'll give some information, and from that we'll have to do the Venn diagram. There won't be enough information to do all of this. There will be some calculation involved in filling in some subsequent ones. But in this case it's all there and we're just going to interpret it. So how many students walk? So how many walk? We have, what, say 21?
Yes.
Okay. So what does it mean to walk? How do you get counted as walking?
You move your feet.
On the diagram, what makes you be counted as walking?
Being in the whole walking circle.
Yeah, being anywhere in the walk circle, right? So whether it's overlapping or not, if you are in the circle walk, it means you walk, right? So we know from this that some students only walk. How many only walk? 11. Okay, so how many only walk? So of the 21 who walk, 11 only walk, right? They have no other means of getting there, no other transportation. How many travel by bicycle, by or car, but do not walk? How many travel by bicycle or car, but do not walk? 48. 48? Don't think so. Oh, well, maybe. Oh, yeah. Yeah, you're right. Okay, never mind. 48. So, how would we express that in set theory notation? So we got bicycle or car. The bicycle or car contains, so how do we get rid of the walk? What's our minus symbol? Slash, right? So we're going to take bicycle or car. Bicycle or car contains anything in the car circle, anything in the bicycle, right? We this plus this plus this plus this plus this plus this. We want to get rid of the walk, so we're going to say minus walk, right? Now, what kind of slash is it? I don't remember. Is it a forward slash? Oh, slash. Where are you? There we go. Okay, so that's bicycle or car minus walk. What do we do for only walk? It's like walk minus bicycle minus car. Right, that'll give us only walk. What do we do for walk? You just W, right? Just the set W. Okay, anything inside the W circle. This is the W circle minus what's inside the B circle, so that'll take care of the 1 and the 7, minus what's inside the C circle, that takes out these two, right, and all we're looking at. So there's a big difference between sort of calculating this and just looking at it on the diagram and figuring it out. And that's mostly where we're going to be going, is just looking at it on the diagram and figuring it out, right, as opposed to setting it up as a set theory calculation. Okay, but you might be asked some of that stuff. All right, what else could we ask? How many students use all three modes? One, right. And how would we express that using set theory? B intersects C intersect W. The intersection of all three, which occurs only in this one spot here. Okay, so car only 24, bicycle only 20, walk only 11, bicycle 32, car 31, walk 21, walk or bicycle, everything inside the walk circle, then plus these guys. If we try and do, there's a thing called the principle of inclusion and exclusion, right? Which says if I'm going to add up, so if I want to do this calculation, let's see here, bicycle or car or walk, and the number of, let's say the number of. So the number of bicycle or car or walk, to do that as a calculation, right? Like let's say that we have written down somewhere, the number that bicycle is this, the number that take the car is this. Like if we had all these numbers down, then we would add up the number that bicycle, we would add up the number that take a car, we would add up the number that walk. Now there's a problem with doing that, right? What's the problem with doing that? So if I take bicycle, which one was bicycle? If I take bicycle, which is this guy, then I'm going to say there's 24, 25, there's 32 that bicycle, right? The number that take the car is 28, 29, 31. The number who walk is 3, 10, is 21. Now how many students are there in total? Just, what's the total number of students in this entire survey?
Oh,
72, right? There's 72 students. What does this add up to? 63, 64, 84. There's only 72 students, so what have we counted twice? We've counted the intersections twice, right? So we're going to have to subtract from that the number who, because we've counted this 4 once as part of, what circle is that? Cars, and once as part of bicycling. We've counted this 1 once as part of cars, once as part of bicycling. So we're going to have to subtract off the number who bicycle or car. But we've counted these guys twice. So we're going to subtract them off. The number who, what was that? Car or walk. But we've counted these guys twice. Oops, you know what, that should be up here. Can I move that up there? Okay, so minus the number who, what did we say that was, bicycle or car, minus the number who bicycle or walk, minus the number, minus the number who car or walk. Okay, so what do we got there? So bicycle or car was how many? 5, right? So we're going to subtract 5. Bicycle or walk is, which bicycle or walk is 8. And walk or car is 3. Okay, so what have we got now? 32, 63, 64, 84. Minus 5 is 79, 71, 68. Oh, we're supposed to have 72. Right, so what's going on?
What is going on?
What is going on? First of all, are those numbers correct? Bicycle, 24, 25, 32. Yes. Car, 24, 28, 30, 31. Yes. Walk, 11, 13, 14, 21. Yes. Bicycle or car. That's this. 5. Bicycle or walk is 8. Car or walk is 3. So what have we done that we need to fix? 84 minus 60, 68. That's 68. Okay. So for this, okay, the number of everything is 72, but we need 69 in here, right? Okay, so we're not counting these 3 because that's not part of this. Bicycle or car or walk is these guys. That's 69. And right now we've got 68. So what have we done that we need to undo? So what we've done is this guy here got subtracted off too many times, right? Because it got subtracted as part of this, part of this, part of that. So we're going to have to add it back in. So plus, oops, that's up here, plus the number who bicycle, intersect car, intersect walk, okay, which is plus 1. So we get what, 63, 84, 79, 71, 68, 69. Okay, so that takes us back up. So there is that formula. You're not given it as part of the formula sheet. You may find it handy in doing some of the questions. I won't expect you to use it in doing questions on the test, which is coming up on Wednesday, right? I expect you more just to be able to count. If I want to know this number, just go in and go 24, 28, 48, 50, 51, 58, 69, right? That's all you really have to do. Okay, but this is showing you that there is actually a formula that you can use if you run into a situation where you have to calculate something, okay, that you can plug into this formula. All right, let's try something else. So here's a problem. A class of 40 students surveyed as to their pets. Or choice of pets, as to their choice of, whoops, as to their, cut it out. As to the pets they would like. They most like. Choices. Cats. Dogs. Birds. Okay. Everybody's got to pick at least one they can, or yeah, so hang on. And say everyone liked at least one. Everyone liked at least one. And here we go, here are the numbers. 10 liked cats and birds, but not dogs. 6 liked cats and dogs, but not birds. 2 liked dogs and birds, but not cats. 2 liked all 3. 10 liked only cats. 9 liked only dogs. 1 liked only birds. Okay, what we want to do is represent these in a Venn diagram, right? So. Okay, so hang on, I can just go. Okay, so. Where do we start? There is a definite starting place. You got to put 2 in the middle. Because the most restrictive set here is liked all 3, right? So there's 2. Okay, now where do we go? So can we go to 10, C and B, no D?
Sure.
Okay, and what do we do?
Put it.
Put it. Put what?
Right on top of 2.
What?
Right there.
What number?
10.
No. No. How many are in this ellipse?
Oh, 10.
There are 10 in there, so there are 8. Right? There are 2 who like all 3. There are 10 who like cats and birds but not dogs. This part here is cats and birds, not dogs.
That's also dogs.
But that's dogs. The twos are the dogs.
Okay, so cats and birds, oh wait, 10. Cats and birds, you're right, so that's a 10 up there. Cats and birds, no dogs. Well, that's a mess. Okay, start over. C, B, D. Okay, 2 there. Cats and birds, not dogs. Right, 10. Okay, what's next? Cats and dogs, no birds, so what do I put? 6. Okay, what's next? 2 in here? Okay. What's next? Well, 10 was cats only, right? So that's cats only. And 9 was dogs only. And 1 was birds only. What do those add up to?
40.
Thank God. What are they supposed to add up to? 40. Good. Okay. All right. So that was actually a pretty easy one. We didn't have to actually calculate anything. Right. So let's do another one where we have to actually calculate something. Wow, there's a lot of pages there. Okay, next one. Super Burger sells hamburgers. Super sells hamburgers. With the choice of ketchup, mustard, and relish. Ketchup, mustard, and relish. One day they sold 256 hamburgers. Hamburgers. 140 had ketchup. $84 had ketchup and relish. Uh, 62 had mustard but no relish. Mustard but no relish. 68 had ketchup and mustard. $38 had all three, and $20 had none. Okay, so let's do this as a Venn diagram, right? So we're going to start off, let me see if I can just slide this up enough to leave all the numbers on. Okay. So we're going to need 3 circles. We'll need a ketchup circle. We'll need a mustard circle. And we'll need a relish circle. And what's the first number we want to put into this?
20.
Sure. Put the 20 in. So 20 had none. They're inside the box but outside the circles. What's the next number we want to put in?
38.
38, right? So you go for the most restrictive, which is all 3. So the 38 goes in the middle there. Okay, now what? 140 had ketchup. Can we deal with that yet? No. 84 had ketchup and relish. Can we deal with that? So what's ketchup and relish? This has to total to 84. So we go 84 minus 38, which is 46, right? So now we have 84 having ketchup and relish. 62 had mustard but no relish. Can we deal with the 62? Not yet. 68 had ketchup and mustard. Can we deal with them? What do we do? So ketchup and mustard would be here. We need 68. We already got 38, so we've got 30. Okay. Now what? What can we do now? We can do the ketchup now, right? We can fill in the rest of the ketchup circle. Because we know that this plus this plus this plus this has to be 140, right? So what do we got? 68, 68, 100, 114. So it'd be 26 who have ketchup only. What next? Now what have we dealt with?
You get the mustard.
We get the mustard?
Yeah. You just subtract 38 from
Okay, so 62 had mustard but no relish. So we need to get rid of the relish, the 38 there. Okay, so that gives us how many? 32. Okay, so what else? So is there anybody in this one? The mustard and we know how many had mustard alone or had mustard total. What else do we have? 30 had all three. 20 had none. 68 had ketchup and mustard. So 84 had ketchup and relish. Check. 62 had mustard but no relish. Check. 68 had ketchup and mustard. Check. 38 had all three. 20 had none. How many people do we have left to deal with? So what have we got total so far? You know what? I think I might have left something off here. Hang on, let me. Oh, you know what? 140 had mustard. Haha. So there's more. 140 had mustard. Oops. Okay, so now we can fill in the mustard, right? Because it really wasn't enough information. So mustard, we got what? 62, 70, 100. So how many go down here? We got 100, so there will be 40 there. Okay, now we can fill it in. So how many people have we accounted for thus far? So we got 20, 60, 92, 122, 130, 160, 206. 212, 232, and there's 256 in total, so we got 232, leaving us with 24. So the last bit there, 24. Okay, sorry about that. I saw the 140 and didn't see the had mustard as well. So 140 ketchup, 140 mustard. So what you want to do is you could start with either the none, right? I mean, the things that are outside the circles. When you go into the circles, if you have this number, that's what you want to start with, right? Because that's what's then going to determine when you've had this and this, right? These are the ands, right? Or would be adding it all together. All right, what else? What else? Oh yeah, one more thing. Yeah, we've done enough of those. Let's say we have this. And we have A, B, C, and I want you to shade the following. A union B prime intersect with C. So A union B prime intersecting with C. So what's the first thing you're going to do? You want to do this, what's the first thing you're going to do? Okay, let's start with this, right? We do this one step at a time. So let's think about the steps that we want to do. First step. So number one, let's do A union B. Okay, and so we'll do that in red. So what do I shade for A union B? A and B, right? Well, it's actually A or B. So we shade everything in the A circle and everything in the B circle. Okay, next step. What's A union B prime? has to do that in green. So it'll be everything that isn't what's shaded in red. So it's all the outer part, right? And this part of C. Okay, so you good? So everything that's green is A union B prime, right? And now we want the intersection of that with C. So let me step 3. So where does that intersect with C? Any colors left? So I got blue left, right? So that's going to be wherever the green and the C meet. Okay, but no red. So it's the blue. Right. So it's just that piece of C that's just C by itself, right? Not C intersecting with anything. Okay. So if you get one of these, and I might give you a couple on the test, just break it down into steps, right? So, well, let me get this first area, right? What is it? Like A union B. Then let me do the prime so that I don't have that. Okay, and then let me intersect that with C, and let's see where we go from there. Okay, let's try another one. B prime intersecting A intersect C. Okay, what should we do first? So what should we do first?
B.
No. 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 What do we do first? Got brackets. What do you do first? You do the brackets first, right? Okay. So we need to do A intersect C. Okay, where is A intersect C? where A and C intersect? Okay. And now we want to intersect that with not B. Okay, which means basically what we want to do then is we're just going to cut out oops, that middle part. The heck did I draw? Yeah. Okay, can I hang on? Control Z. Okay, good. All right, well, here. All right, so then all we're going to be left with, whoops, A, B, C, is this here. So it's the intersection of the red with the part that's not B, which means we take out this little chunk here because that's where B is, right? So it's the intersection of the red, A intersects C, intersecting with not B, which means we need to take out that piece. Okay, so that's the final. This is all right, well, let's try. Let's do one more. A prime minus, which way does the minus slash go? Is it like that? Is it that way or the other way? This way? I don't use it enough. Wait, I got a formula sheet here. No, it's not even on the formula sheet. Okay, so A prime minus the intersection of B union C.
Isn't that union?
Union. Yeah, A prime minus the intersection of B union C. So what do I want to start with?
Brackets.
Brackets, okay? So what am I shading? Do that in red, right? Okay, B union C, right? Where it's all of B and all of C, everything that's in the circle B and C. What's A prime? Everything but A. So the A prime would be well, there it is. We'll just do A prime. A prime would also include this, right? Not any intersections of A. Trying to stay away from the A. So we want all of this, and from that we want to subtract this part.
So it's just everything outside the circles.
Yeah, so it's just everything outside all three circles. Oops, A, B, C. Okay, there we go. Okay, so mostly interested in three circle Venn diagrams, not having to know the principle of inclusion exclusion formula, right? Although that is listed for you on page 50. It's not given to you on the formula sheet, so it's not something that you're going to expect you to to know that formula, but you'll be using it without really using it, right? Like you're not going to be writing it out, but you'll be using it just when you're filling in the diagrams, right? So just remember, you start with the most restrictive part if you can, and you fill your way out from there. You can take a look at the examples in the book, and then the questions are on page 51. This is our last section of set theory. So tomorrow's review, there's chapter self-test, chapter review, etc. And Wednesday will be the test. Okay, so short unit. Another short unit.